In this video we're going to continue to set up our template for our typical use of this SoMachine project. In the previous video we went through setting up our main in sequential function chart, and that's what we see here, and it flows just like a function chart. These are some conditions that need to be met just so that it can pass to the next block. If we double click on these blocks, we can open them up and we can choose the language that we're going to use. Now typically in a template I'll use sequential function chart, structured text, and function block diagram, and it will depend on what we're doing as to which is the preferred method. In this particular case I'm going to use structured text, and I'm just going to add a simple block that sets our machine init done to true, and that satisfies that block. It satisfies this conditional that it must be true to pass in here. And we have one here, and we're going to do the same thing in this one, and we're going to use structured text, and we're going to do the same thing. So now we have machine init done is true in here, devices init done is in here, and typically what we're going to do in these is these sections are used to configure or initialize the entire machine. Okay, so that could be a turntable, reset to turntable, it could be doors, it could be safety items, things of that nature. And then in our init devices routine, this is typically used to configure or initialize devices. And the devices can be they could be anything that's connected over Ethernet, over Modbus serial, Modbus TCP. It could be servo drives, it could be AC drives, things of that nature. This is where we would define some default values for them, speeds, and that sort of thing. So, and then what we're going to do is, typically in these programs for SoMachine, is that there are a couple of I/O defaults that should be set, and we're going to use the same setups for this entire template. Now the inputs by default come into this word, and the word contains 14 bytes, and that defines what the inputs are. Since we can't double define them or dual define them, I have to delete the word, and then we're simply going to define this as di_00, and that matches the ix0.0. So that's going to be pretty typical of what we do. So we're going to go down through and we're going to define them. And you'll see the method behind this madness. It will actually start to make sense as we get further through this. Now we can either call this, it's your preference, there's no wrong answer, but typically I will change when the I/O changes. So you got ix0.7, and then it goes ix0.8, because these are obviously 8-bit words, and then we need to go into the next word. And then the other thing is that this I/O channel actually defines it as I8, or input 8. So you can either continue with di08, or you can call it di10, your preference. I typically define them as the I/O designator, so that way I know where it's actually coming from. And what it corresponds to. So then we're going to do the same thing with our outputs. Since our outputs can't be dual defined, the first thing we have to do is delete the word that brings in all of the outputs. And DQ is digital output, or Q is output. I don't know how they get Q, but that's what it is. So there's all of those, and we're going to save this, and we're just going to save it in your folder of choice. I would suggest that when you save SoMachine projects that you give each one its own folder, because SoMachine does create several files that are associated with that project. So back in SR main, we're going to go into inputs, and we're going to actually use function block diagram in this. So now what we're going to do is we're going to insert an assignment. So what we want to do is we want to take our di00 and we want to move it into a variable, and we're going to use the variable in our program instead of the actual input. And that way, if things evolve, things change, and you need to move a variable or you need to move an input, you can do it in this one place instead of having to search your entire project to find where you've done that association. And this you can call anything. And then because it doesn't exist, it wants to do an auto declare. And we would actually do that for all 14 inputs, and in this section we would do all 12 outputs. Remember, things get left to right as far as an assignment, so it moves them from this side to this side. So it takes our output that we use in our program, our variable we use in our program, and it moves it to the output. And this way, when you use this template, you don't ever have to change the I/O in the actual I/O assignment or in the modules. You can change them in software. So now if we compile it, we make sure we didn't make any mistakes. There's one warning, and the warning is simply because by default SoMachine wants some check bounds, and we can turn that off easy enough.